right, so for this first one, we have the terms of the series listed out. And so we're going to need to figure out what is that first term and what is r that we're multiplying by. So the first term is that 3/2, and then r is what we're multiplying by to generate the list of numbers. So I would look at the numerators and denominators separately. For the numerator, we're multiplying by 3 each time. And for the denominator, we're multiplying by 8 each time, so 3/8. And so the sum of the series is going to be 3/2 over 1 minus 3/8. And so this would be 8/8 minus 3/8, which would be 5/8. And when you divide by a fraction, that's going to be the same as multiplying by the reciprocal, so multiplying by 8/5. And so that's going to give us 24 over 10, which would be 2.4. So that one is going to be C. All right, this next one is real weird, and we're going to need a calculator for this. Notice you have all these decimals here. It's summation 1 to infinity of this sine squared of x to the k. They also use k instead of n, which, you know, it's fine. It's just a different letter of the alphabet. But if you like n better, you can switch those k's to be n's. Then find f of 1. So what we need to do is plug in 1 for x and see what we get. I'm also going to put a 1 right here. This is going to be 1 times whatever sine of 1 squared is to the k power. So you pull out the calculator, and I'm going to do sine of 1 squared. So lots of parentheses for that, or you can always do sine of 1 times sine of 1. Sine of 1 squared is going to give me 0.708. And we are going to need to reuse that, so I'm going to go ahead and store it, store alpha A, enter. So I've got that captured, so 0.708. So A is 1, which is a little tricky because there was nothing written in there, but you can always just put a 1 there. And what I have stored here is that R value. So the sum is going to be 1 over 1 minus 0.708, but that's if this starts at 0. Instead, we started at 1. So remember, if you don't start at 0, you have to subtract out those first couple of terms that got left out. Now, in this case, only the k equals 0 term is what got left out. But like, say this started at 4, you would have to leave out 0, 1, 2, and 3. You know, so whatever ones get left out, you just have to subtract off at the end. So I'm going to subtract off what we get when k is 0. Now 0 is a convenient number to work with. Anything to the 0 power is 1, and then times 1 would be 1. So we're going to subtract 1 from that. So typing this in the calculator is going to give me my answer. So it will be 1 over 1 minus that stored value, and then subtract 1. So this problem was really weird because you had to, you know, store this decimal and then also subtract off one of the missing terms. So this one was really tricky. 2.425. And so that one is D. Oh, no, I'm sorry. Oh, did I say that right? Yeah, 2.425. All right, so D. Oh, E is the same thing, except if you forgot to, do you see what they did there with E? If you forget to subtract out the 1, they make that another answer, and it almost tripped me up for a second. So be really careful. All right, so number 3 looks like a gigantic mess. So what I'm going to do is just list out the first few terms. I think that's always helpful just to notice the pattern. All right, so this is, if we plug in 1, we're starting at n being 1. So if I plug in 1, that's going to be 2 squared, so that'll be 4. And then down here, 3 to the first is 3. And then if I plug in 2, this will be 2 cubed is 8, and 3 squared is 9. And then if I plug in 3, 2 to the fourth would be 16, and 3 cubed is 27. You want to do like at least 3 or 4 terms so that you can see the pattern, but then we can rewrite this starting at 0, so we're not leaving anything out, and we just need the first term and then times r to the n. So the first term is 4/3, and then it'll be r to the n. So let me ask you guys, what are we multiplying by each time to generate the pattern for this series? What is our r value going to be? Good, 2/3. Awesome. The numerator is getting multiplied by 2, and then denominator is getting multiplied by 3, so 2/3. And so the sum is the first term over 1 minus r. And so this would be 3/3 minus 2/3 would be 1/3. And so the 3's are going to cancel, and that gives you 4/1, which is 4. So C for that one. All right, for this one, it says x and y are positive real numbers. Which of the following conditions guarantees that this infinite series will converge? All right, so this is A, and then this is R. And in order to converge, we need R to be smaller than 1. So this x over y squared has to be smaller than 1. And I know it's absolute value, but they told us that both x and y are positive, so we don't need to worry about the absolute value here. And so I'm just going to multiply over the y squared. And so it's x less than y squared. So that one is D. All right, for this one, a sub n equals 1 for all positive integers of n. What is the value of s sub n? So that's a partial sum for n terms. So like if you add up the first 7 terms, that's s sub n. The nth partial sum for this infinite series. So it's the summation from n equals 1 to infinity, and this a sub n, they said, is just 1, like literally just 1. So if you want to list out, some of the partial sums, like let's just do the first 3. Say do at least 3 or 4. So the first one's just going to be 1. And then the second one would be 1 plus 1, so 2. And then the third one would be 1 plus 1 plus 1, so 3. I mean, every single term in the series is going to be 1. So the first one is 1, and the second one is 2, and the third one is 3. So it's just always going to be whatever term you're on, whatever n is. So that one is B. All right, for 6, we've got a sub k equals -1 to the k. So this is going to alternate. Whenever you have a -1 to a power like that, it's going to flip back and forth. Which of the following statements is true about the infinite series? Starting at 0 for -1 to the k power. So let's just list out the first few terms. So starting at 0, if we plug in 0, -1 to the 0 power, that's just going to be 1. If we plug in 1, we're going to get -1. And then if we plug in 2, we're going to get +1. And if we plug in 3, we're going to get -1. Oops, I said 3, so I can't write a 3 there. And it's just going to alternate back and forth, so forever and ever. So there is no pattern to this. It's not like headed anywhere. It's not leveling off anywhere, and so the series diverges. You're just going to keep getting +1, -1 forever. So it's not headed anywhere. All right, and then last one. Again, this looks kind of like a disaster, so I'm going to just write out the first few terms just to see what the pattern is, and we're starting at 1. So if I plug in 1, this is going to be -3 squared, that'll be 9, and then 5 to the first is 5. And then if I plug in 2, 2 plus 1 is 3, -3 cubed would be -27, and 5 squared is 25. Then I'll just do one more. If we plug in 3, this will be -3 to the 4th, that'll be 81. And then down here, 5 to the 3rd is 125. And so I'm going to rewrite it starting at 0 because that's where we need to start for our geometric series. And it'll be a times r to the n. So a is the first term, so 9/5. And then we want r to the n. So again, I want to ask you guys, I'm hoping you get a few responses here. What are you multiplying by each time to generate the pattern? And look at the numerators and denominators separately because that can help. What are we multiplying by each time to continue the pattern? And yeah, good. -3/5. Awesome. It needs to be negative because we're alternating each time. And we're multiplying by 3 in the numerator and then by 5 in the denominator. So -3/5. So this sum is going to be 9/5 over 1 minus -3/5. So that'll be +3/5. So that is 9/5 over, let's see, this would be 5/5 plus 3/5 would be 8/5. And the 5s are going to cancel, so 9/8. And so that one is D.